Alright, so in this video, I want to take a look at using the translation theorems to see if we can find a Laplace transform of this function here, e raised to the 3t times t minus 4 squared. So we notice that this has a form very similar to example 1, right, where we had an e raised to the 5t times an f of t, which is cosine of 3t. So this is the exact same process. It might be a little bit harder to see because we have this t minus 4 squared. It looks like there's more stuff going on there, but in fact the t minus 4 squared is just an f of t. It's just a function of t, and we actually will open this up, we'll factor, distribute everything out, and we'll see that, well, it's just an f of t, and this is our e raised to the at, so that means that our a is going to be 3 according to Form 1 of the translation theorem, because it looks very similar to Form 1, so that's why we're going to use that one. So as we said, f of t is t minus 4 squared. We're going to factor everything out. That's going to get, it's going to be equivalent to t squared minus 8t plus 16. Step 2 is to find big F of s, which is the Laplace transform of f of t, which is this t squared minus 8t plus 16. Using the table, we have 2 factorial over s raised to the 2 plus 1 minus 8 times 1 factorial over s raised to the 1 plus 1, and the Laplace of 16, which Laplace of a constant is just that constant over s, but you can formally write it also as 16 times 0 factorial over s raised to the 0 plus 1, and 0 factorial is 1. 1 factorial is also 1. So we have 2 over s cubed minus 8 over s squared plus 16 over s. That's our big F of s. And we just simply plug in the s minus 3 into the big F of s. So everywhere we see an s here, we're going to plug in s minus 3. So we get s minus 3 cubed instead of just regular s minus 3. Here we have s minus, here instead of regular s, we have s minus 3. And so on in this case, right? S minus 3 instead of regular s, and then s minus 3 instead of just s. So that is another example of using the first translation theorem to find the Laplace transform.